Okay, so in this first video, we're going to start talking about motion, right? So that's our first idea that we're going to study. And we need to define a few quantities that are going to help us express the ideas mathematically. So first we need to define position, then we need to define displacement, right? So displacement, which is just basically change in position, and then we need to define velocity, and then finally acceleration. So we are going to go through the definition of these quantities, and these are the key important quantities that we need when we talk about motion or kinematics, which is the study of motion. So motion, what is motion? Well, it's a change in position, but we don't know what position is. So we are going to look at that. But you sort of have an idea of what position is. This ball here is changing position, right? So how do you formally define the position? Well, so to define the position, you need a coordinate system. You need a reference, right? You need to say this car is 4 miles from the post office. So then you set your zero, your origin, at some point, in this case, the post office. Then you have an axis, right? So you have a line here. You have some units, and then you can tell where the car is by using the units, using that line, and you say that this car is 4 miles from this reference, from this zero, right? So the position can be positive if it is on this side and can be negative if it is in this other side. So this combination is called a coordinate system, and that's all you need to define the position. A position is basically a point in a coordinate system. So a coordinate system is an axis with an origin, in this case 0. We name the axis. In this case, the axis is named x. This means it has units of, in this case, meters. It could have other type of units. So this is your coordinate. In this case, this lady is at the position 20 meters in this coordinate system. So when the position changes, then we have a displacement. So in physics, we are going to talk about changes. Physics, in a way, is a study of physical changes. So to express changes, we are going to use this upside down triangle, and this is called delta. And it's a Greek letter, and is typically used to denote changes. So in this case, so there is some object here that starts at this point and ends at that point. So this is your initial position, and this is your final position. So the change in position is always defined as final minus initial. In this case, final position minus initial position. So here you have a final position of 150, initial of 50, and then you would have that this is just 100. 100 what? Well, the units here are feet, so this is 100 feet. That's the displacement. So the displacement can be negative. You could go, say, start here at 100 and move all the way to 50, right? So in that case, your initial position is 100, your final position is 50, and your displacement would be what? Would be final minus initial, which is 50 minus 100, and that is minus 50, so that is a negative displacement. So the displacement has a length, in this case 100, in this case 50, and it has an orientation, right? In this case is positive, and in this case is negative. Negative here. In the same way that position changes, time is always changes. You can look at your clock, at your watch in your wrist, and then you'll see that time is changing. So, and we are going to talk about time intervals. In this case, we have an object that is moving, right? So the position goes from 0 to 20 from 0 to 20 to 40 to 60 and so on. And it does that at 0 seconds, 1 second, 2 seconds, and so on. So then the time interval here, delta t, is just 1 second. So in going from, say, from here to here, if you go, say, from 80 to 120, right? So the displacement is delta x is equal to 120 minus 80, which is 40. And delta t, the time interval, is 6 minus 4 seconds, which is equal to 2 seconds. So now we are ready to define velocity and speed. Velocity is a quantity that encodes two pieces of information. It tells you how fast you're going and the direction, right? So you could be going positive or negative in this case. So the speed is just a quantity that tells you how fast you're going. Is the speed doesn't change over time. We said we have a constant speed motion. And so the speed is basically the distance that you travel, which is the magnitude or the length of your displacement, divided by the time interval. For instance, let's say you go from 40 to 80. So what is your displacement? Your displacement is 80, which is your final, minus your initial is equal to 40 feet, right? So that is your displacement. The distance that you travel, d, is 40 feet, right? So what is your velocity? Your velocity is equal to 40 divided by the time that it took to go from here to here, and that time is 2 seconds, right? Because it takes 1 second in go from here in going from 80 to 100, and another second in going from 100 to 120. So the velocity is 40 divided by 2 seconds is equal to 40 feet over seconds, right? So that's your velocity, and in this case it's positive. Now let's say that you go from, say, 100 to 40, right? So you start here at 100 and you go to 40. What is your displacement? Your displacement is, well, final, which is 40, minus initial, right? So that gives me minus 60. It's a negative displacement. What is your distance travel? Well, the distance is just the magnitude of this displacement, which is just 60. So the velocity then, the velocity is a negative number. So you have 3 seconds here, right? So that is also minus 60 divided by 3 is equal to minus 20 feet over second. That is your velocity. And what is your speed? Your speed is 20. The speed is 20 in this case. But it's a positive speed. This is always positive number. So that brings us to the definition of two important objects that we use in physics, scalars and vectors. Scalars are just numbers. They encode just one piece of information. In this case, in the previous case, would be just the distance or the speed. Vectors are objects that encode two pieces of information, the magnitude and the orientation. Typically, a vector is denoted by an arrow. So the length of the arrow tells you about the magnitude, and where the arrow is pointing tells you about the orientation. So let's look at examples of vectors here. We have displacements. Those are vectors. This displacement goes from here to here. That's your vector, right? So you could have a displacement that goes the other way. So that will be another type of displacement with the same magnitude. This displacement goes from here to here, right? So that's a vector that goes from this point to this point. So when we use vectors, we need to use a few tricks from trigonometry. So you need to remind yourself of these things if you don't remember, and if you need help with that, please just let me know. This is going to be very important. You have Pythagoras, you have sines and cosines. You need to remember that. You need to remember how to calculate this size of a triangle using the sines and cosine. The inverse trigonometry functions are very important. And finally, you need to know how to use these inverse trigonometry functions to get this angle if you know the size of a triangle. So velocity vectors, so we have displacements as vectors, so then we can also have the velocity. So here you have an object that is moving, right? So you can see that changes positions. These blue vectors are displacements. So if I take these blue vectors and I divide them by the time, I get the velocity vectors, which are these green vectors. The longer this vector, it means that the object is going faster. Here, the longer the blue vectors means that the displacement is greater. Okay, so this is all for this video. So please review your trigonometry if you don't remember, and I'll see you in the next video.